So in this presentation, we're going to be talking about condensate pumps. If you're installing a 90% condensing furnace or an air conditioner with a coil, you're probably looking at a condensate pump, unless you're lucky enough to drain the condensate by gravity. This is the typical condensate pump setup. They have mounted it here on the side of the furnace. Sometimes they just sit on the floor, but there are a variety of ways they can be set up and powered, and we'll be discussing that in this video. So in this slide, we see a breakdown of condensate pump and what it's made up of. On the top is the motor that runs the impeller that draws the water up into the tube and out of the space. You have your pump switch, and there's also a float in the tank that will turn the pump on when the water gets to the point where it trips the switch. So you need to be aware of all these components that make up the condensate pump. A number of months ago, I was called on a job where they had a large unit like this, where you could walk into the blower section, and the unit was putting water on the floor, and so there was a problem with the condensate draining out of the system. And of course, they thought it was a system problem, and they wanted us to try to resolve it and fix it. A factory rep accompanied me on this job, and so I made him the volunteer to get inside the unit, and we shut the door and turned the blower on. It didn't take long before he yelled out that he knew what the problem was. When he opened the door, he said, "I see what the problem is. The static of the blower is overcoming the drain, and it's pulling the condensate out of the drain and not allowing it to flow out of the condensate tubing." So we had to put a bigger trap on that unit, and once we did that, it drained correctly and there was no more water on the floor. So the reason that we put a condensate pump on a furnace or an air conditioning coil is to drain the condensate water away from the system and outside. If the water or condensate does not drain out of the coil or the furnace, then we have defeated our purpose. This slide shows the positive pressure that is caused by the blower blowing through the furnace and the evaporator coil. Positive pressure is all throughout the furnace and the coil and extends into the condensate piping. If this is allowed to remain this way, this will hold the condensate into the furnace or the coil, and it will not drain correctly. This picture shows two things that should never be done on a condensate drain that is put on a coil or a furnace. The first thing is the cap on the top of the PVC pipe for the drain. It has been capped instead of left open as an air gap. The second is the shallow running trap. These shallow running traps that are sold by most parts departments are not deep enough to overcome the positive pressure that we just talked about in the blower section. And these kind of traps will allow the coil or the furnace to hold the condensate into the system and not let it flow out of the furnace or the coil to drain to the outside. So these shallow running traps are not recommended and should never be used to run the condensate for a coil or a condensing furnace. Instead, a trap that has a 3-inch and a 2-inch drop should be used so you have enough pressure to overcome the positive pressure that is exerted upon the condensate by the blower. We showed on a previous slide the cap that they put on the top of the PVC piping for the condensate drain, and we mentioned that that should be open as an air gap. In this particular diagram, we have an AC coil on top of the furnace, and you have the PVC coming down to tie into the furnace condensate, and there should be an air gap there as well. You should consult the installation guide for the particular furnace that you're installing to make sure that this is the proper way that they want you to run the condensate. So whether you're running your condensate by gravity or it has to go through a condensate pump, you need to have a termination point. And many people use a drain that may be in the floor of a laundry room. Some people will use an under the sink attachment to drain it through the sink in the bathroom or the laundry room. If you do this, please make sure that you check the local codes to make sure that it's okay to do that. The reason that you need to check local codes is that some local codes regulate the amount of condensate that they allow into their system. A chart, usually in a bulletin or the product data for the furnace, will tell you how many gallons per day that a certain furnace will produce. In this case, you see that a 140,000 BTU furnace will produce 10.5 gallons of condensate per day. It also will tell you what the composition of the condensate is. And you notice on the left-hand side that you have chloride, fluoride, and nitrates and sulfate. Nothing that's really going to damage anything. They've said that the condensate of an average 90% condensing furnace is about like orange juice as far as acidity or caustic characteristics. So if you're having an issue with an inspector or local code, you should look into a neutralizing filter that's available to run with the condensate line that will neutralize the condensation out of a gas furnace. This will make it acceptable to the inspector and will meet the local codes. Once you've run your condensate piping, the next thing you need to do is wire the condensate pump in. And the way that it's wired in is very important. I had a case a while back where they had a mystery that every time the technician would leave, the homeowner would call a couple hours later and say that the furnace had tripped out and condensate pump malfunction. And then when the tech would go up to the attic and check out the furnace, everything was fine. He'd leave, a couple hours later, they'd get a call that the furnace was out again on condensate failure. To make a long story short, what they finally found out was that the installers had wired the condensate pump into the light switch for the attic. So every time that the technician went up to check on the furnace, he turned on the light and the condensate pump worked fine. When he left the attic, he turned the power switch for the light off, thus turning the condensate pump off too. And then after a couple of hours, the furnace would fault out on failure. So make sure you don't wire your condensate pumps into a light that you turn on and off when you go up to the attic. So on most condensate pumps, there are two different connections you need to make. The first one would be the power connection. Normally, condensate pumps are usually plugged into an outlet that is either mounted on the furnace or near the furnace. But this needs to be a constant power supply that is never interrupted. The second connection that is made is the safety switch on the condensate pump, so that if the float or the condensate pump itself fails, it will shut down the condensing furnace and will not allow condensation to keep building up, which could overflow and do damage to the home. So as we stated, the condensate pump power should be plugged into an outlet that is provided at the furnace or near the furnace, but needs to be a constant power source that is never interrupted. And also the safety switch should be wired in case that the pump fails, that it will shut down the furnace or the AC so condensate will not build up and overflow and damage the home. Also with condensate pumps, there needs to be regular maintenance performed on them, as they will build up corrosion and debris over periods of time. If you have a condensate trap like this on your air conditioner or furnace system, you'll see this garbage and debris that builds up in these traps. This is why this particular model is sold with a brush so that you can run it through and clean out the trap. The same thing needs to be done to the condensate pump. So over a period of time of running, a condensate pump is going to build up various debris and gunk in the bottom of the tank. And so it's very important as part of your maintenance that you would open it up and clean out the tank and make sure that it's not corroded up like this. This is very important so that the float continues to work properly, the switch continues to make, and the pickup tube that delivers the condensate to the condensate tubing to the outside does not get plugged up. So when you're doing maintenance on a condensate pump, a few things you want to make sure when you're putting it back together: to make sure that the float is operating freely and the switch is making and breaking. Make sure the impeller that picks up the water in the tank is free and clear and is working properly. And make sure that the check valve in the discharge tube is working freely so that it does not get plugged up and allows the water to run back into the condensate pump on the off cycle. All these things you should check at least twice a year when you're doing maintenance on these condensate pumps.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.